Good morning, students. Am I audible, visible? Write in the chat box. Am I audible, Abhinash? Abhinash, Gayatri, Rohit, Sasmita. Am I audible? Write in the chat box. Hello. Okay. So let's start. Function. Different types of functions, their domain, their range, their properties, and their graphs. Okay. Already we have finished constant function and polynomial function. Today we will discuss about the graph of polynomial functions, right? So polynomial function, it is defined as y is equal to f of x is equal to a0 plus a1x plus a2x square plus up to an x to the power n, where a0, a1, a2 up to n are real constants and the power of x can't be a negative number or a fraction, right? Where a0, a1, a2 up to n are real constants, our power of x can't be a negative number or fraction. For example, f of x is equal to 2x plus 3. It is a polynomial function of degree 1. F of x is equal to x square minus 3x plus 2. It is a polynomial function of degree 2. F of x is equal to x cube minus x is a polynomial function of degree 3. Degree means the highest power of the variable. Okay. Let us come to discuss about the domain of a polynomial function. What do you mean by domain? Domain is the largest set or subset of a real number over which a function is defined. Already I have discussed it in the last class. So if the function is f of x is equal to a0 plus a1x plus a2x square plus up to anx to the power n, if you substitute a real value in place of x, then real into real is real, real plus real is real, and real minus real is real. For a unique value of x, there exists a unique value of y. So we can say that this function or polynomial function is defined for all real values of x, hence the domain of a polynomial function is R. Domain of any polynomial function is R. If the question is find the domain of the function f of x is equal to 2x plus 3, you can write domain is equal to R. The domain of the function f of x is equal to x square minus 3x plus 2, domain is R. Domain of the function f of x is equal to x cube minus x, domain of the function R. So domain of any polynomial function is R. Then come to a range of a polynomial function. A range is the set of obtained values of the function or set of functional values of the function, right? Very, very important note point. A range of an odd degree polynomial function Range of an odd degree polynomial function.
New meeting.
Range of an odd degree polynomial function is R, and the range of a even degree polynomial function depends upon its degree and structure. Okay. If the function is f of x is equal to 2x plus 1, and question is find the range of the function. Range of the function will be R because it is an odd degree, first degree polynomial function. Odd degree polynomial function range is R. If the function is f of x is equal to x cube minus x, it is also an odd degree polynomial function. Range of the function is R. That means an odd degree polynomial function is capable of assuming any real value. An odd degree polynomial function is capable of assuming any real value, right? Another note point, range of the function f of x is equal to ax square plus bx plus c each four ac minus b square upon 4a to infinity if a greater equal to 0 minus infinity to 4ac upon b minus b square upon 4a if a less than 0. Sorry, not a not equal to a greater than 0. Right, quickly note it down. I'll explain why the range of the function f of x is equal to x square plus bx plus c is equal to 4ac minus b square by 4a to infinity if a greater than 0, and minus infinity to 4ac minus b square upon 4a if a less than 0. Quickly note it down. Come to the proof. F of x is equal to ax square plus bx plus c. F of x is equal to ax square plus bx plus c. If you take a as common, a whole into x square plus b upon a times x plus c upon a. Okay, now we have to convert this expression in the bracket into perfect square. So this is equal to a into, in class 10, you know how to convert a quadratic expression into perfect square. So half of a square of the coefficient of x should be added and subtracted. So x square plus b upon a times x the coefficient of x is b upon a, and half of coefficient of x will be b upon 2a, and square of the half of the coefficient of b upon a. So square of b upon 2a will be b square upon 4a square. Okay. Plus c upon a. Already we have added b square upon 4a square. To nullify, we have to subtract the same amount. That is b square minus b square upon 4a square. I hope it is clear to you. Now you see, this is a square, this is b square, and this term is 2ab. That will be a plus b whole square. This is equal to a times x plus b upon 2a whole square plus. Now we have to add these two terms. The LCM is 4a square. 4ac minus of b square. Right? This is equal to, now multiply a with this by distributive property. A into x plus b upon 2a whole square plus of 4ac minus b square upon 4a. Right? Guys, I'm giving an example. Suppose x is a variable and x is greater or equal to 5. Suppose x is a variable and x is greater or equal to 5. That the minimum value of x is 5. If you take the number line, put 5, then the value of x is 5 or greater than 5. We can say that the range of x is 5 to infinity. Okay. If x be a variable such that x is less or equal to 10. If x is a variable such that x is less or equal to 10, then you can say that the range of the x is minus infinity to 10. Range of x belongs to minus infinity to 10, right? So, you know, square quantity is always positive. We can write x plus b upon 2a whole square is greater or equal to 0. Okay. In the expression ax square plus bx plus c, a is the leading coefficient. A can never be equal to 0. If a is equal to 0, then it won't be considered as a quadratic. A is either greater than 0 or a is less than 0. Case 1, consider a is greater than 0. A is greater than 0. X plus b by 2 whole square is greater or equal to 0. A is greater than 0. If we multiply these two terms, then we'll get a times x plus b by 2a whole square greater or equal to 0. Right? 4ac minus b square upon 4a is a constant quantity. All of you know, if a constant quantity is being added to both sides of an inequality, then symbol of the inequality remains unchanged. Now add 4ac minus b square upon 4a to both sides of this inequality. So this implies a times x plus b by 2a whole square plus 4ac minus b square upon 4a is greater or equal to 4ac minus b square upon 4a. Right? This expression is the simplified version of the expression ax square plus bx plus c. So in place of this expression, we can write ax square plus bx plus c. So ax square plus bx plus c is greater or equal to 4ac minus b square upon 4a. Okay. Since x is a variable, so ax square plus bx plus c is a variable expression. The variable expression is greater or equal to 4ac minus b square upon 4a. That means if you consider this one as y, the right hand side expression is a constant. Let it be 5 or 10 or 7. Okay. If y is greater or equal to 7, then we can say that range of the expression is 7 to infinity. So ax square plus bx plus c is a variable expression and its minimum value is 4ac minus b square upon 4a. Maximum value approaches to infinity. Hence, we can say that the range of this expression is 4ac minus b square upon 4a to infinity. Okay, I hope it is clear to you. Write in the chat box, is it clear? Divyanka, Rohit, Arman, is it clear? Shubham, write in the chat box, is it clear to you? Did you understand? Okay. So range of the expression ax square plus bx plus c is 4ac minus b square upon 4a to infinity if a greater than 0 minus infinity to 4ac minus b square upon 4a if a is less than 0. Yes, sir, but I didn't understand the cases. Can you explain again? Yes. Cases means yes. So ax square plus bx plus c is equal to nothing a whole into x plus b by 2 a whole square plus 4ac minus b square upon 4a. You know, x plus b by 2 a whole square is a square quantity. A square quantity can never be negative. Either it is positive or 0. So x plus b by 2 a whole square is greater or equal to 0. Now to get this expression, we have to multiply a to both sides of the inequality x plus b by 2 a whole square greater or equal to 0. So if just try to understand, 3 is greater than 2. If we multiply a constant quantity to both sides of the inequality, first of all, we have to check whether we are multiplying the positive constant quantity or negative constant quantity. If a positive constant quantity is multiplied to both sides of the inequality, symbol remains unchanged. If a negative quantity is multiplied, then symbol will be reversed. For example, if you multiply 2 to both sides of this inequality, 6 will be greater than 4. But if you multiply minus 2, negative 2, minus 6 will be less than minus 4. That's why we have to take two cases, a greater than 0 and a less than 0. I hope it is clear. Hello? Akarshak, did you understand? Okay. Then we have to take another case, that is a less than 0. Quickly note it down, or if possible, I will create a space here also. Okay. Better to go next, please. Ax square plus bx plus c. Oh, sorry. Ax square plus bx plus c equals to a whole into x plus b by 2a whole square plus 4ac minus b square upon 4a. Ax square plus bx plus c equals to a whole into x plus b by 2a whole square plus 4ac minus b square upon 4a, right? We have to deal with the second case. We have x plus b by 2 whole square greater or equal to 0. Case 2, either a is positive or a negative. Already we have discussed a is positive. Now take the case a less than 0, a is negative. If you multiply negative quantity with a positive quantity, then the product will be negative. This implies a into x plus b by 2a whole square less or equal to 0. Now add the constant term 4ac minus b square upon 4a to both sides of the inequality. That will give you a times x plus b by 2a whole square plus 4ac minus b square upon 4a is less than equal to 4ac minus b square upon 4a, right? You see, the left hand side is nothing, the simplified version of the expression ax square plus bx plus c. So in place of a into x plus b by 2 whole square plus 4ac minus b square upon 4a, we can write down ax square plus bx plus c. So ax square plus bx plus c is less or equal to 4ac minus b square upon 4a, right? Ax square plus bx plus c is a variable quantity. It is less or equal to 4ac minus b square by 4a. That means the maximum value of the expression is 4ac minus b square by 4a, and the minimum value will be negative infinity. So we can say that when a less than 0, range of the function is minus infinity to 4ac minus b square upon 4a. Got it? I hope it is clear. Please write in the chat box. Is it clear to you? So that I'll proceed ahead. Akarshak, is it clear? Pratisha, yes. Okay. So write down a question. Find the range of the functions. Find the range of the following functions. Yes. Try to solve these 3 questions. Send me the answer. The first one is a polynomial function of degree 5 or degree polynomial function. Hence, range of the function is R. The second function is a polynomial function of a degree 2, and it is in the form of ax square plus bx plus c. If we compare the expression with ax square plus bx plus c, then we get a is equal to 1, b is equal to minus 5, and c is equal to 4. Okay. The leading coefficient a is greater than 0. Hence, the range of the function is 4ac minus b square upon 4a to infinity. 4ac is equal to 16 minus b square is minus 25 upon 4a is equal to 4 to infinity. Okay. This is equal to minus 9 upon 4 to infinity. The second one can be written as minus x square plus x plus 0. Here a is equal to negative 1, b is equal to 1, c is equal to 0. If a is less than 0, then range of the expression is 0 to infinity. Which one? Pratisha? 0 to infinity. Okay, let me solve the question. This is R. This is minus 9 upon 4 to infinity. The third one will be minus infinity to 4ac is 0 minus b square upon 4a minus 4. This is equal to minus infinity to 1 by 4. Last one is minus infinity to 1 by 4. Okay. Then a very, very important note point. If a polynomial function satisfies the condition if a polynomial function satisfies the condition f of x into f of 1 by x equals f of x plus f of 1 by x, then f of x is equal to plus or minus x to the power n plus 1. So very, very important note point. If a polynomial function satisfies the condition f of x into f of 1 by x is equal to f of x plus f of 1 by x, then f of x is equal to plus or minus x to the power n plus of 1. Come to the proof. F of x into f of 1 by x is equal to f of x plus f of 1 by x. Now taking f of x into the left hand side, the expression will be f of x into f of 1 by x minus f of x equals f of 1 by x. Now we can take f of x as common. This implies f of x times f of 1 by x minus 1 is equal to f of 1 by x. So this implies f of x is equal to f of 1 by x upon f of 1 by x minus 1. Let it be equation 1, right? Then I'm replacing x by f of x. Sorry, replacing x by 1 upon x in the equation 1. Replacing x by 1 upon x in equation 1. F of 1 upon x is equal to f of x upon f of x minus 1. This is equation 2. Now multiplying equation 1 and 2, write down multiplying equation 1 and equation 2. Multiplying equation 1 and equation 2, f of x into f of 1 by x is equal to f of 1 by x upon f of 1 by x minus 1 into f of x upon f of x minus 1. This implies f of x into f of 1 by x is equal to f of x into f of 1 by x upon f of 1 by x minus 1 into f of x minus 1. Okay. These are two non-zero factors. We can cancel f of x into f of 1 by x from both sides of the equation. Okay, cancelling the common term, we'll get that is f of 1 by x minus 1 into f of x minus 1 equals to 1. So guys, quickly note it down. It is which class maths? 11 class? Tuna, it is 11 class maths. It is 11 class means 11 class JEE syllabus. IIT JEE syllabus, not the board syllabus. Okay. So f of x minus 1 into f of 1 by x minus 1 is equal to 1. Okay. If product of two quantities equal to 1, if product of two quantities equal to 1, then we can say that the two quantities are reciprocal of each other. F of x minus 1 and f of 1 by x minus 1 are reciprocal of each other and x1 upon x is also reciprocal of each other. So this is possible only when either this term or this term is a monomial. This is possible either f of x minus 1. F of x minus 1 is a monomial, means either you can take x or you can take minus x or you can take x square, you can take minus x square or x cube minus x cube. This is possible. If you take f of x minus 1 is equal to x, then what will be f of replacing x by 1 by x? F of 1 by x minus 1 will be 1 upon x and their product will be 1. Suppose if you take f of x minus 1 is equal to x to the power n, then f of 1 by x minus 1 will be 1 by x to the power n and their product will be 1. So this is possible. The above equation is possible, implies f of x minus 1 is equal to plus or minus x to the power n. This implies f of x is equal to plus or minus x to the power n plus of 1. This is the proof. Right? So guys, write down a question on this concept. The question is, if a polynomial function satisfies the condition, Akarshak, is it clear? Akarshak, did you understand what I explained now? Pratisha, Pritesh, write in the chat box. Is it clear? Vishwajit. Okay. So write down a question. If a polynomial function okay, let me know, are you comfortable in my language? That means if you want Odia, I can teach you in Odia also. Are you comfortable in English? Or okay. So let's move right on the question. If a polynomial function satisfies the condition if a polynomial function satisfies the condition f of x into f of 1 by x is equal to f of x plus f of 1 by x and f of 10 is equal to 1001, find f of 20. If f of 10 is equal to 1001, then find f of 20. Solve it and send me the answer. Write the answer in the chat box. What is the answer? Gayatri, Abhinash, Akarsak, Sashinandan Das. Beautiful name. Vishwajit, Pratisha. What is the answer to this question? F of x into f of 1 by x is equal to f of x plus f of 1 by x. This implies f of x is equal to plus or minus x to the power n plus 1. So f of 10 will be f of 10 is equal to plus or minus 10 to the power n plus 1. It is given that f of 10 is equal to 1001. So this implies plus or minus 10 to the power n plus 1 is equal to 1001. Answer asila gutte. Yes, Akarsak, it is 801. You are absolutely correct. Okay. So this implies plus or minus 10 to the power n is equal to 1000. So negative sign is not possible. So 10 to the power n is equal to 1000. This implies n is equal to 3. Thus f of x is equal to x cube plus 1. Thus f of x is equal to x cube plus 1. This implies f of 20 is equal to 20 cube plus 1, which is equal to 8001. 8001 is the right answer. So guys, could you note it down? Hope it is clear. Then write down rational polynomial function. Rational polynomial function. Rational polynomial function. It is defined as y is equal to f of x equals to p of x upon q of x. It is defined as y is equal to f of x is equal to p of x upon q of x, where p of x and q of x are polynomials in x, where p of x and q of x are polynomials in x. For example, f of x is equal to 2x plus 3 upon 3x minus 1. This is a rational polynomial function. F of x is equal to 4x plus 1 upon x square plus x plus 1 is a rational polynomial function. F of x is equal to x square minus x plus 1 upon x cube minus x. This is also a rational polynomial. These are the some examples of a rational polynomial function, right? Now, how to find the domain of a rational polynomial function? If a function is of the form p of x upon q of x, f of x is equal to p of x upon q of x. Here the numerator is the polynomial p of x and denominator is the polynomial q of x. In a rational form, in a fraction, suppose a upon b. If the denominator is 0, then the fraction will be undefined. Okay. So when q of x is equal to 0, the expression of the function will be undefined. And the domain means the set of values for which the function is defined. So if the function is of the form f of x is equal to p of x upon q of x, then domain f, D stands for domain. Domain f is the set of all x such that, domain is R, that is set of real number, minus set of all x such that q of x is equal to 0. Clear? The points at which q of x is 0 should be subtracted from the set of real numbers. The points at which q of x is 0, the function will be undefined at those points. Clear? Suppose the question is find the domain of the function f of x is equal to 2x plus 3 upon 3x minus 1. This expression will be undefined when the denominator is 0. Here the denominator is 3x minus 1. 3x minus 1 is equal to 0. Implies x is equal to 1 upon 3. So for x is equal to 1 upon 3, this function is defined. Otherwise, it is defined for all real values. Now we can say that the function is defined for all real values except 1 upon 3. Hence, the domain of the function is equal to r minus 1 upon 3. Did you understand, guys? Write in the chat box. Is it clear to you? Okay. So write down some question. Find the domain of the following functions. Yes, I can explain it again. TG part. What do you mean by TG part? Can you explain again? The part or I think explain the part. Okay. Okay, let me explain it again. The function is f of x is equal to 2x plus 3 upon 3x minus 1. The question is to find the domain of the function. What do you mean by domain? Domain is the set of values of x for which function is defined. And in a rational expression, you know that a rational expression will be undefined when the denominator is 0. Something by 0 is always undefined. That's why it is called division by 0 is not permissible. So this function, if you put x is equal to 0, the value function is defined and value is equal to -3. If you take x is equal to 1, function is defined, the value is 5 upon 2. So we have to find those values for which the function is defined. It is better to, because the values or the points at which the function is defined is infinite and the values at which the function is undefined is finite. So we have to subtract the undefined values from the set of real number. Where it is undefined, the function will be undefined only when the denominator is 0. That is 3x minus 1 is equal to 0. X is equal to 1 by 3. For x is equal to 1 by 3 function is defined. For all other points except 1 upon 3, it is defined. Hence, the domain of the function is r minus 1 upon 3. Akarshak, did you understand now? Now is it clear to you? Akarshak, write in the chat box. Okay, then write down the question, find the domain of the following functions. Find the domain of the following functions. Solve it. Solve and write the answer in chat box. First one is R minus 1, second one is R minus 2, 3. First one is R minus plus or minus 1. Second one is correct, R minus 2, 3. Gayatri, you are correct. Second answer is correct, but first answer is incorrect. First answer is partial correct. Fourth is R minus 0, 1, minus 1. Yes, correct. Fourth one is R minus 0, plus 1, minus 1. Correct. What is the fifth one? A third one? Yes, R minus 0, 1, minus 1. Pratisha, you are also correct. Okay, let me solve all the 4 questions. The question number 1, f of x is equal to 2x plus 1 upon x square minus 1. First of all, we have to find out the values of x for which the denominator is 0. Here the denominator expression is x square minus 1. X square minus 1 is equal to 0. This implies we can factorize it as x plus 1 into x minus 1 is equal to 0. So this implies x is equal to 1 or negative 1. For x is equal to 1 and a negative 1, the function is undefined. Otherwise, the function is defined for all other values in the set of real number. Hence, the domain of the function is r minus 1 and minus 1. I hope it is clear to you. Then question number 2, f of x is equal to 3x plus 4 upon x square minus 5x plus 6. F of x is equal to 3x plus 4 upon x square minus 5x plus 6. X square minus 5x plus 6 is equal to 0. This implies x minus 2 into x minus 3 is equal to 0. Implies x is equal to 2 or x is equal to 3. So domain of the function is r minus 2 comma 3. I hope it is clear. Then come to question number 3. Question number 3, f of x is equal to x square plus 2 upon x cube minus 6x square plus 11x minus 6. Okay, the function will be undefined when the denominator is 0. Here the denominator is a cubic equation. Now you'll think that how to handle this question. Okay, how to factorize it or how to get the roots of the equation x cube minus 6x square plus 11x minus 6 is equal to 0. Okay. You see in this equation, sum of the coefficients is equal to 0. What are the coefficients? 1, minus 6, 11, minus 6. Minus 6 plus minus 6 will be minus 12. 1 plus 11 will be 12. 12 minus 12 is 0. Since you sum of the coefficients is equal to 0, so x is equal to 1 must be a root. If you substitute x is equal to 1, you will get sum of the coefficients. Since x is equal to 1 is a root, so x minus 1 is a factor of that expression. So x cube minus 6x square plus 11x minus 6. So x minus 1 is a factor of this expression. That means the expression x cube minus 6x square plus 11 minus 6 is completely divisible by x minus 1. By long division, we can find the quotient. So x square, so x cube minus x square minus plus minus 5x square plus 11x minus 6. Now I can take minus 5x square plus 5x plus minus, so 6x minus 6. Then we can take 6x minus 6, which is equal to 0, right? So x cube minus 6x square plus 11 minus 6. If we divide it by x minus 1, the quotient is x square minus 5x plus 6. and the remainder is 0. From division algorithm, you know that dividend is equal to divisor into quotient plus of remainder. Dividend is equal to divisor into quotient plus remainder. So we can write x cube minus 6x square plus 11x minus 6 is equal to x minus 1 into x square minus 5x plus 6. Now you can easily handle this expression. It can be factorized by middle term factorization. This is equal to x minus 1 into x minus 2 into x minus 3. Thus x square minus x cube minus 6x square plus 11x minus 6 is equal to 0 implies x minus 1 into x minus 2 into x minus 3 is equal to 0. This implies x is equal to 1 or 2 or 3. Okay. So domain of the function is r minus 1, 2, 3. Domain of the function is r minus 1, 2, 3. Akarshak, Pratisha, is it clear? Gayatri? Okay, then question number 4. F of x is equal to square plus 1 upon x cube minus x. Okay. Now solve the equation x cube minus x is equal to 0. This implies x into x square minus 1 is equal to 0. This implies x into x plus 1 into x minus 1 is equal to 0. Implies x is equal to 0, x is equal to 1, or x is equal to minus 1. Hence, domain of the function is r minus 0, 1, minus 1. I hope it is clear to you. Then come to range of rational functions. Now we will be able to find the range of some special type of rational functions, not all rational functions. Okay. To find the range of every rational function, we should know derivative, differentiation, okay, maximum and minimum values. Range of rational functions of the form f of x is equal to linear upon linear, that is of the form ax plus b upon cx plus d, or f of x is equal to type 2, f of x is equal to linear upon quadratic, that is ax plus b upon px square plus qx plus r, or f of x is equal to quadratic upon quadratic. Quadratic upon quadratic. That is of the form ax square plus bx plus c. Upon px square plus qx plus r. Px square plus qx plus r. Okay. There is a working rule to find the range of such functions. Write down the working rule. Working rule, or you may say that stepwise approach. Step 1. Express x as the function of y. Step 2. Find the values of y. Find the values of y for which x is defined Step 3. The set of values of y. The set of values of y obtained in step 2 is the required range. Okay. The set of values of y obtained in step 2 is the required range. We will note it down. Now we will discuss couple of questions. Done, finished. Should I go to the next page? Okay. Gayatri, you are from which school? BJV Higher Secondary School. Good. So question is, find the range of f of x equals 2x plus 3 upon 3x minus 1. And the range of the function f of x is equal to 2x plus 3 upon 3x minus 1. First find the range in procedural method, then I will give you the shortcut how to find without doing anything. Come to the solution. Procedural method, y is equal to 2x plus 3 upon 3x minus 1. Y is equal to 2x plus 3 upon 3x minus 1. So taking all the terms by cross multiplication, y into 3x minus 1 is equal to 2x plus 3. This implies 3xy minus y is equal to 2x plus 3. This implies 3xy minus 2x is equal to y plus 3. Now you can take x as common from the left hand side. It will be x times 3y minus 2 equals y plus 3. This implies x is equal to y plus 3 upon 3y minus 2. X is equal to y plus 3 upon 3y minus 2. The first step is over. The first step was to express x as a function of y. Okay. Now we have to find out the values for which y is defined. So better to find where x is defined. Better to find where x is undefined. Now x is a rational expression. X depends upon a rational expression in y, that is y plus 3 upon 3y minus 2. You know, rational expression is undefined only when the denominator is 0. If 3y minus 2 is equal to 0, then x is equal to x is undefined. 3y minus 2 is equal to 0 implies y is equal to 2 by 3. Y, that means the function can't give you the value 2 by 3. So x is defined for all real numbers except 2 upon 3. So range of the function is r minus 2 upon 3. I hope it is clear to you. Gayatri, Akarshak, is it clear? Yes. What is the shortcut formula to find the range of linear upon linear without doing anything? We can calculate the range of the function linear upon linear directly if the function is, so note it down. Better to use the next page. If y is equal to f of x is equal to ax plus b upon cx plus d. Now analyze what is the range. The range is the set of functional values of a function. This function can give you any real value except a upon c. This function can give you any real value except a upon c. That means if you substitute ax plus b upon cx plus d is equal to a upon c. This implies ax plus b is equal to a upon c into cx plus d. This is equal to ax plus ad upon c. So ax plus ax cancels, b is equal to ad upon c. This implies bc is equal to ad. This may not be true. bc is equal to ad. This may not be true. That's why we can say that the range of the function is r minus. It is capable of giving you any real value except a upon c. So directly you can write range of the function is r minus a upon c. Let us come to an example. Suppose f of x is equal to 4x minus 1 upon 3x minus 2. What is the range? Range of the function is r minus 4 upon 3. It can give you any real value except 4 upon 3. Okay, now equate 4x minus 1 upon 3x minus 2 with 4 upon 3. 4x minus 1 upon 3x minus 2 is equal to 4 upon 3. So 12x minus 1 cross multiplication is equal to 12x minus 8. 12x cancels. So minus 1 is equal to minus 8. 1 is equal to 8. This is mathematical absurd, right? So if a function is of the form ax plus b upon cx plus d. Then range of the function is r minus a upon c. Did you understand? Is it clear to you? This is the shortcut we can apply if a polynomial function is of the form linear upon linear. Pratisha, Smita, Sasmita, is it clear? Okay. So I think this session is over now. Your second session is zoology. Okay. And the session will be started at exactly 9:15. Stay connected. So guys, if you want to take the advantage of this class, every class you have to attend. Otherwise, if you skip any class, then in the next class you can't understand. Okay. From JEE point of view, these classes are very important for you. PPT का chat box रे share करंतु. Okay. ମୁଁ ତ PPT ବନେଇନି. From next class onwards, I will. Okay, next class onwards, I will upload the PPT. PPT means question bank. Some questions. The first session is over. Second session will be zoology.